parabola is going to go through here, go a little above here, going to come down here. It's going to be symmetric. And it's also going to have zeros here, right? The way I've drawn it, if this is 2.6, we might say the x-intercept would be, what do you think? This is 0 and this is 2.6, and one unit would be about this far. That'd be about maybe 2.9. And another x-intercept here, which would be maybe negative 0.4. How could we find the x-intercepts? Well, the x-intercepts occur when y equals 0, right? Okay, so if we plug in okay, we plug in now this isn't y anymore, it's h, and actually this should be t-intercept because this is t, right? So our t-intercept occurs when h equals 0. Well, h of t is negative 5t squared plus 15t plus 11. So h equals 0 means that this expression for h is equal to 0. And you can figure that out easily. That's just the quadratic formula again. So t is negative 15 plus or minus the square root of 15 squared, which is 225, minus 4 times negative 5 times 11 over 2 times negative 5. Now you got to remember the quadratic formula, but then, once you're used to it, it's real easy to do this. And since I wrote it out for you in the quiz, everybody appears to have done okay with that. I haven't looked closely, but I believe you probably did. Well, this is negative 15 plus or minus. That's 225. This is 20 times 11. That's 220. So you get 400 square root of 425 over negative 10. That's negative 15 over negative 10. Plus or minus approximately. Square root of 425 is about 20.5. Okay? Which is negative 1.5 plus or minus 2.05, which is well, negative 1.5 plus 2.05 is going to be, I've got a sign wrong here somewhere. I get 0.55 or negative 3.5. Now, if the 0.55 was negative, that would agree with the negative 0.4, right? So something's wrong with what I did here. Can you see it? See what I did wrong? I never do anything wrong, so it's hard to see. Four times 5 is 20, times 11 is 220. Is that? Okay, that's good. And well, this isn't negative 1.5, it's plus 1.5. Okay. Now I'm getting negative 0.55, but I'm also getting 3.5, and 3.5 doesn't really fit. I still don't like what I've got. But that's what I've got. So basically, the idea is, if you got the equation of parabola, you can figure out when it's 0, and that's going to give you this point and this point. And you can always get the y-intercept. You just plug in t equals 0 in this case. So the y-intercept is going to be that number in the end. So you get the zeros and the y-intercept. And just from that, you can pretty much draw the picture. Okay? If you have additional information, you can do this. And there's a big thing. The vertex is at negative b over 2a. I'll remind you, I'm pretty sure I've said it, quadratic formula is negative b plus or minus the square root of a bunch of stuff over 2a. This doesn't matter if you're just trying to find the vertex. Of course, it matters if you're trying to find the zeros, right? And you will usually do that, but right there is the coordinate of the vertex, right? So vertex is at negative b over 2a. Well, you know, that's here. And of course, that simplifies to this and to this. And you're going to get 1.5. So now this point is where t equals 1.5. This is called the axis of symmetry. It corresponds to the y-axis on your basic squared function. And to get the coordinate here, the coordinate here is 1.5, h evaluated at 1.5, because of course you plug in the time into here to find out how high it is there. Okay? Now that's a big deal. That's really pretty much most, probably 90% of what we do in pre-calculus for a quadratic function. And it's really a big deal, because you can use this to figure out how you transform the basic x squared function to get that graph. Now, we don't have time to talk about it today, but we're going to talk about it probably next time. Okay, very good.